Planned burns like these are a challenging and rewarding balance of managing fire to achieve objectives of fuel hazard reduction and ecological benefit. Important to predicting the success of a burn is being able to accurately foresee potential fire behaviour. To predict fire behaviour, the following needs to be known: the weather, topography, and knowledge of the fuel condition, both the moisture and arrangement. This fuel element is also the only part that we as land managers can modify, and with a changing climate, this task of managing fuels becomes even more complex. That arrangement of the leaves and twigs, the shrubs and type of bark all have a direct impact on the way a fire moves through the landscape. Currently, Victoria uses the overall Fine Fuel Hazard Guide to measure fuel, and whilst this has been an effective tool to consider vegetation arrangement, it is subjective and variable between assessors, with hazard scores varying over several categories, as you can see in the top left. Remote sensing, on the other hand, in the solid lines gives us a much tighter agreement. These visual-based assessments are also very difficult to scale to broader areas. This research project, 3D remote sensing of fuels, takes on this challenge to develop an accurate, rapid, scalable, and fit-for-purpose solution, and is being completed with RMIT University. To achieve this, innovative techniques are being used to build point clouds. This is like a 3D model or virtual reality of the landscape that you can see here in the top left. To build these models, we use a laser scanner and digital cameras like the one sitting on your phone, and we can do this from the ground or from drones. From this information, we can look at replicating existing fuel metrics, including horizontal and vertical coverage and height, the percentage of live and dead vegetation, and we can also investigate new metrics to look at the way fuel is connected across the profile, like in the top right-hand corner. Initial results have been promising, with strong correlations between ground-based scans and destructive techniques. Work has begun at 3 pilot locations around the state to scale up ground-based assessments to wide-scale airborne measurements from drones and aircraft, allowing us to characterise fuel properties over a larger area. An important element of this research is the development of an operational methodology so that we can go out and implement this research program going forward. These new procedures are repeatable, don't rely on existing user knowledge, and have proven their accuracy. Discovering the utility of 3D point clouds to accurately measure fuel attributes facilitates a paradigm shift in the way fuel information is captured and models validated. To reiterate, we started here, wanting to measure fuel structure accurately. We use ground-based and airborne techniques to measure 3D structure, and we do this because we want to make more informed decisions about risk quantification and fire behaviour when we're out here, ultimately benefiting emergency organisations and the Victorian community. Thanks for listening.